Hello everyone, I am Akanksha, team leader of Code Wizards from BMS Institute of Technology and Management, Bangalore. Along with my teammates Nimisha, Nikhil, and Saad, we are excited to present our hardware based solution developed for the CodeRed 3.0 competition. Our project, Multi Sensor Wildlife Corridor Monitoring System for anti poaching using ESP32 and Raspberry Pi, is our problem statement, and the code is CRH3. We choose this hardware problem statement because we wanted to build something that directly impacts the real world, something that does not just run on servers or apps or on any website, but actually works in remote environment where technology usually fails. Forest and wildlife zones, they face really threats every single day, and most exciting existing and monitoring system simply they cannot operate in harsh and core conditions or in disconnected conditions. That is where our project comes in. The main problem we are addressing is the increasing threat to wildlife reserves and forest corridors due to poaching, illegal logging, and then unauthorized human entries into the forest area. Today, monitoring in forest largely depends on few points, that is, manual patrolling by forest guards, or camera traps, or drones, or network dependent IoT systems. However, all these have major limitations like manual patrols, they are very slow, risky, and inconsistent, whereas the camera traps, they are very expensive and they can easily get damaged, and they perform poorly during nights. Drones, they cannot work 24 bar 7 as they'll have limitations of flight time. And most importantly, many forest areas have zero network connectivity, which makes real time alerts very impossible. So, this leads to delayed response, and in many cases, authorities only discover incidents after damage has already been done. To solve this, we designed a system that can monitor forest continuously even in most remote areas. Our idea, that is Forest Eye, a smart AI driven edge monitoring tower that acts like a digital forest guard. So, what all our Forest Eye can do? It can listen to gunshots, footsteps, or vehicle sounds using acoustic sensors. It can detect human movement using motion and thermal sensing sensors. It can analyze the data locally using TinyML and Raspberry Pi, which we have embedded in the electronic board. Then it can also send instant alerts through long ranges that here we are using LoRa communication. The key concept is that all decision making happens on the tower itself without any need of internet or any cloud servers. This makes it extremely reliable in forest department areas or environment. In simple words, I can just tell that Forest Eye is a self sustaining, intelligent surveillance which bubbles and then it catches the intruders or poachers before the human even knows that something wrong is going to happen there. Now, let me explain about the prototype setup. Here, as we can see in the slide, our prototype, it consists of ESP32 S3 microcontroller, Raspberry Pi, acoustic sensors, PIR motion sensor, thermal or IR sensors, LoRa communication module. And how it works, going to the working. This is how our workflow goes. The sensors, they continuously monitor the surroundings for sound, movement, and heat signatures. The ESP32, then it acts the first layer and detects all the sensors data using TinyML modules. If something suspicious is detected, the data is then forwarded to the Raspberry Pi. The Raspberry Pi also, it performs its function by detecting the data, and then it'll analyze the data using heavier ML models and further sensor fusions. If both of them, that is the ESP32 and Raspberry Pi, both agree that if there is some threat or any issue, and if it is verified, then an alert will be generated. That alert is transmitted through LoRa, that is long range communication, to our dashboard. Even from deeper forest region also. The dashboard displays the event and it will then notify the forest personals, and an SMS will be sent to the range for immediate action. This is how our actual prototype works in our real time. Then there are few advantages also of our project. It works in zero networking zone using the LoRa. It uses very extremely low power with deep sleep modules. And then we are using multi sensors, which will reduce false alarms. Then real time action alerts are also given within seconds. We can tell that our prototype is very scalable because multiple towers it can generate a cover range grid. It is also rugged, which means that it can work 24 bar 7. Then, coming to the last and main important thing, that is the uniqueness of our project. That is, most existing system they only focus on the monitoring and recordings. Here, and they just store the footages and then data that need to be retrieved later. By the time someone checks it, the incident would have already happened. So our solution it mainly focuses on the prevention and rapid responses. So what are the main unique things of our forest eye? The first thing is zero dependency detection, which means that all the processing will happen locally on edge. That is using ESP32 and Raspberry Pi. Here, no cloud or no internet is needed here, and this will make it reliable and remotely used in forest. The next thing is multi-sensing, multi-sensor fusion. Here we don't trigger any alert based on just one sensor or something. Here we combine many sensors, like we combine sound, motion, thermal, data, and dramatically, which will reduce all the false alarms. The next main thing is event driven power architecture. Here the system will sleep whenever it is not in use, and only whenever it is active it works. So here we can save battery, and then it can be used for long term long range communication. Here we are using LoRa communication, which can be used even in deep forest. Then coming to the last thing, that is scalable grid. Here multiple towers they can form an intelligent network covering large forest corridors. So to conclude, Forest Eye it aims to protect wildlife by providing real time, reliable, and then low power monitoring in areas where technology normally cannot reach. So with future development, this system can support forest departments, wildlife conservations, NGOs, and even border security applications also. Thank you, and we look forward to turning this prototype into a real world impact. Thank you.